Hi, welcome to the online lecture series for the course 805 on microcontroller. In this lecture, we will be discussing the multiply and the divide instruction in 8051. The syntax is mul AB. So there is no space between A and B. Okay, so mul, use space, then AB. What does this instruction do? This instruction multiplies the contents of register A with the contents of the register B, and it stores back the result in both A and B. How does it store back? Now see here, register A is 8-bit, register B is also 8-bit. So when you multiply two 8-bit numbers, so the maximum result can be 16-bit. Fine. So that's why after multiplication, register A contains the lower byte of the product and register B contains the higher byte of the product. For example, if I am multiplying say FF into FF, so I will copy FF into register A and FF into register B. So the result I will get is FE01. So 01 is the lower byte of the product and FE is the higher byte of the product. So the lower byte of the product will be present in accumulator and higher byte of the product will be present in the register B. That's the meaning of it. Fine. And which are the flags affected? So you have to be careful here. If the product is greater than 255, that is FFH, then overflow flag will be set. So if you have two numbers, after the multiplication of those two numbers, if the result is greater than the 8-bit, so your overflow flag will be set. Otherwise, it will be cleared. The carry flag is always cleared. Fine. The other flag which will be affected is the parity flag. Okay, so the parity flag will be affected based on the contents of register A. If it has got odd number of ones, so it will be odd parity, and if it has got even number of ones, it will be even parity. Let us take an illustration. So I have moved 10 to accumulator and 10 to register B. Now remember, this is decimal 10. Okay, I have not written H here. Okay, so it is decimal 10. So 10 into 10 is 100. Okay, but in hexadecimal, 100 is represented as 64H. So after the execution, so since the result is only 8 bits wide, so you will see 00H in B and 64H in register A. Come to the second example. I have moved FFH in accumulator and I have also moved the same number in B. Fine. So when you multiply, the result is FE01. Okay. So 01 is the lower byte of the result, so that will be in the accumulator, and FE is the higher byte of the result, that will be in the register B. Fine. So let me quickly show you here. So A contains FFH, B also contains FFH. Then I will say multiply AB. See the demo of this. And this is unsigned multiplication. We don't have something called signed multiplication. Okay. The accumulator has got FF. B also has got FF. Okay. So when you multiply FF into FF, the result is FE01. That is, you will get a 16-bit product. So after the multiplication, your register A contains the lower byte of the product and register B contains the higher byte of the product. So I will execute. You can see the lower byte of the product 01 is present in accumulator. The higher byte, that is FE, it is present in register B. Let's see the next instruction, that is divide AB. The syntax is divide space AB. So again, in this case, there is no space between A and B. What does this instruction do? This instruction divides a unsigned byte in register A by a unsigned byte in register B. So after division, your quotient will be in register A and remainder will be in register B. Fine. What are the flags affected? So if you attempt to divide by 0, first of all, whenever you perform division operation in any of the programming languages, you should ensure that you are not dividing it by 0. It leads to uh, greater problems. Fine. So if you divide by 0, the values in the register A and B are undefined, and overflow flag will be set indicating that the result is invalid. So overflow flag will be only set when you attempt to divide by 0. That is, if your register B is 0. In this case also, the carry flag is always 0. Parity flag will be affected based on the contents of register A. Let us take an example. I have moved decimal 9 to accumulator and 2 to B. So 9 by 2 is quotient is 4, remainder is 1. So after the execution, accumulator contains the quotient and register B contains the remainder. Now as you can see, the parity flag is 1. Why? Because 4 means it has got odd number of ones. In fact, only one bit will be 1. That's why it is parity flag is equal to 1. In the second example, B contains 0. So since B is 0, this will lead to divide by 0. And what will be in A and B, it is undefined, and overflow flag is set. Let us quickly have a demo of this. Okay. So I will take some other example. Say I will take decimal 64, or I will take 66, and I will take 8. Okay, I will take a simple number so that you understand. 9, and this is 2. Okay, and this is divide. So A contains 9, B contains 2. So after the execution, A will have the quotient, B will have the remainder. Okay. So as you can see, B has got 1 and A has got 4, which is the quotient. Okay. So that's all about the multiply and the divide instruction. Thank you.